Hi there, this is AGNR 131 Soil Science Exercise 4 or Lab 4 Part 1, and this is the final week. This is the closeout of this particular experiment. So as you can see, here's our experiment, and at first glance things look pretty good. So if you recall, this was a soil drainage, restricted drainage, and just regular drainage experiment. We looked at two different soils. We looked at a native soil, just soil that we got from around here that was native, and then we used a potting mix that we use here in the greenhouse. So the point was that we were going to compare the potting mix and the native soil, and we were going to have one treatment that was allowed just to drain as it wanted to, and then another treatment with the same soil. We were going to actually restrict the drainage, and we did that by putting plastic on it. So let's have a look and see what actually happened here, and let's do a little speculation as to maybe what might have happened in this particular experiment. So I don't know if I'm going to give you all the answers, because I may actually have you come up with that, but I'm going to explain just a little bit of what's going on. Let's start with the cucumbers first of all. So if we take the native soils, I'll pull these out so we can see them. We had the native soil right through here, and you can see that the one that was allowed to drain freely. And if you recall, what we did was we measured, we poured water through here till it came out the bottom, and then we knew how much water we'd put in, and then whatever came through the bottom here, we poured that back into our volumetrics and subtracted that from the total amount that we'd put. Once we got that, then we poured that same amount of water into the same soil, but the one with plastic on it. So the idea is that the water would go down, get to the bottom of the plastic, but it doesn't escape from here. So this would be empty. So here we go. We have our native soil here, and as you can see, there's not much to see. There's a little bit of grass right through there, but that's not a cucumber. And then we have the cucumber right through here. There's 3 plants. There's also some grass growing in that. Looks pretty good. Looks pretty good. So in this case, this restricted drainage, the cucumber seems to have liked that and have been happy with it. Now let's go to our garden greenhouse soil, our nursery soils, and let's look at the same thing. So here you can see our non-restricted drainage. This is the same thing. Water was allowed to come through the bottom, and then we put the same amount of water in here. Comparing these two plants, it looks like the one with restricted drainage, in other words, the one that all the water was captured, didn't hurt the plants at all. So have a look at those. Look how healthy they are, and then we'll come and we'll look at the next set. If you recall, we did 3 different kinds of plants just to see if there'd be any difference in the plants. So next, let's move to the pumpkins. I'll start with the native soils again. Here's the one that had the non-restricted drainage. The leaves down here are a little bit yellow, but these are the first leaves anyways. You'd expect those to be yellow. This is the leaves that the seed itself provided the energy for that, and once the plant got its second set of leaves up, these ones with a different look to them, they're able to do their own photosynthesis, and these plants here are really not, these leaves down here really not doing anything. So this is not like this is unhealthy. This is expected, right? As a pumpkin would grow. So here you go. You've got your non-restricted drainage here in your native soil, and you've got your restricted drainage. Again, so I want you to look at those 2 plants, and the soil's the same. The only difference is that they received the same amount of water, but the water in this one wasn't allowed to escape. This water here could evaporate freely. Okay, so that's the native soil, and then let's look at the nursery soil. Comparing it to the other plants, first of all, these 2 here are our nursery soil, and these 2 here are our native soils. I want you to see that first of all, and kind of get an idea of difference. It looks like the plants are larger and maybe just generally more robust in the greenhouse or the nursery mix, if you will. So again, the non-restricted over here, and I've got 3 or 4 plants there, and then the restricted over through here. These tend to look a little bit more robust, slightly better, and perhaps slightly better condition. So the one thing I will say, well, let's finish the last ones up first, and then we'll do a little bit more talking. The last would be the tomatoes. And you can see that we did get some tomatoes up on this one. This is the non-restricted. So these guys apparently received all the water they wanted. This should have received more water than it needed, but you can see the difference that's going on through this. So at this point, the experiment has actually not worked out the way I expected. Okay, so we have it kind of backwards, and I want you guys to kind of think what's going on through there. Okay, as I finish this thing up, I would have expected that the plants that had the restricted drainage might have gotten too much water, because these guys we watered quite regularly, and every time we watered these guys, we watered the ones with restricted drainage as well with the same amount. So the restricted drainage all the way through, though, tends to look better. And of course the gardens, the nursery soil, the greenhouse soil, if you will, that mix, the plants look better generally, except for the tomatoes. They look better in that one than they do in the native soil. Okay, so there's two different things going on there. Let's have the final look here. This is the only interesting one. Here's the non-restricted greenhouse soil, and then here's the restricted. And you can see this one has got water sitting on the top. However, interestingly enough, this tomato doesn't seem to be too bothered. I'm not sure why he's not bothered, or she's not bothered, or it's not bothered, but it's not. It's actually the largest plant of them all. And you can tell the water's been there for a while because we've got that nice algae on the surface. So I mean, that's not just something that we just did today. That's been there for a while. So what's going on with that? What's the difference between restricted drainage and non-restricted drainage? Okay, so you need a little bit more information. The experiment, as I said, didn't work out the way I expected. However, it worked out just fine for us thinking about soil management, and that's really the goal of this whole class and all these exercises. So we had a problem with our native soils, which may or may not have contributed to that. The native soil being much heavier, much denser, when it dried out, it tended to separate a little bit from the edges. It would pull away from the edges like this. It's not going to do it, but it would pull away from the edges like that, just in dry cracks. So when we watered that, at first we weren't really sure that, we weren't really paying attention to that. So what would happen is the water might end up going around these cracks down here, and then it would drain out the bottom. So the bulk of the soil may not be getting wet, okay? So we would still measure that amount of soil, I mean that amount of water that came through, we'd put it into the other ones, which didn't have any drainage in the bottom at all. Follow me? So this one here, we would put water in. Most of that water may have gone down the cracks, and then we would subtract that amount off from the total we put in, and then we would put that same amount of water into the pots with restricted drainage. As I said, the pots with restricted drainage tend to look better. They tend to look better. I want you to help me understand what's going on there and speculate yourselves. What we did after that was, when we saw cracks like that, we went ahead and pushed the sides in like that before we actually watered it. So we just pushed the sides in so that the water would not be able to run down the sides between the soil and the pot. So I wanted you to understand that we did that. So let's take one final look at this. Cucumbers again, native soil in the front, greenhouse soil in the back. Look at the difference. I'm going to switch these around just a little bit. Pumpkins, native soil in the front, and then there's the natives, and then greenhouse soil in the back, and then finally you just saw the tomatoes, native soil in the front, and then the greenhouse soil in the back. So next thing will be your questions and some questions on this experiment, but hopefully you'll have learned something by it, and based on the questions, I'm sure you'll be able to get a chance to speculate. That's the end of this particular experiment.